Running changes the question. Imagine a mountain lion 50 yards down a forest trail. It is not growling, crouching, or charging. It is simply watching an upright human who is watching back. Then the human turns. One step becomes three, the backpack bounces, and a quiet standoff becomes a moving target. That is the strange paradox. Across much of the world, wildlife treats humans as unusually dangerous. Ecologists sometimes call us the super predator. Yet when we meet another predator, every alarm in our own body demands the same thing: get away, now. That instinct can be useful in ordinary danger. In front of a large carnivore, however, the sudden retreat may provide exactly the kind of motion its hunting system already knows how to follow. The important word is may. Running does not magically turn a person into prey, and predators do not share one universal kill switch. But movement can change the problem their brain is trying to solve. The paradox begins at waterholes in South Africa's Greater Kruger region. Researchers hid speakers and cameras, then played ordinary human conversation, lion sounds, hunting noises, or harmless birds. Across 4,238 independent trials involving 19 mammal species, wildlife was about twice as likely to run from human voices as from lions. Animals also abandoned the waterholes roughly 40% faster. Calm conversation beat the king of beasts. This matters because the predator watching our runner is not starting with a blank opinion. A standing human can be an unpredictable opponent. Hunger is only one part of the calculation. Distance, posture, surprise, escape routes, previous experience, and whether the animal is defending young all matter. The predator must choose among caution, investigation, defense, and pursuit. While the runner remains upright and faces it, the answer stays uncertain. Turning away does not create hunger. It changes the evidence, and evidence can change which action becomes easiest to launch. A hunt is not one red button marked attack. It is a sequence. Detect something, orient toward it, approach or chase, then capture and bite. Neuroscience experiments in mice help separate these stages. They do not prove that a cougar, bear, or wolf experiences a human encounter in exactly the same way, but they reveal an important design principle. In one study, outputs from the central amygdala helped organize pursuit through the midbrain periaqueductal gray, while a different route toward the brainstem coordinated the neck and jaw movements used for biting. Disrupting one pathway did not simply erase the entire hunt. Other work found groups of periaqueductal gray neurons becoming active at different moments of searching, chasing, attacking, and consuming. In other words, predation is assembled from modules. A predator can notice without pursuing, pursue without immediately biting, or abandon the sequence when risk becomes too high. The dramatic moment is not a monster awakening. It is one behavioral stage gaining priority over its competitors. So what does running add? First, rapid movement away from the observer. Second, a clear direction that can be predicted. Third, a turned back and a lower, narrower silhouette. Fourth, repeated acceleration that keeps attention locked onto the same target. Visual research on hunting animals shows how strongly pursuit depends on tracking where a target is going, not merely recognizing what it is. A stationary person supplies complicated information: tall posture, forward-facing attention, strange clothing, and the possibility of fighting back. A retreating figure temporarily compresses that complexity into speed and trajectory. Our red tracking ring is a useful metaphor. One segment marks detection, another marks direction, a third marks acceleration, the last marks a path that can be intercepted. Real brains do not display glowing circles, unfortunately. Wildlife documentaries would be much easier to edit. But the metaphor captures the shift. Running does not stamp the word food onto a human. It can make pursuit a clearer, more familiar option than continued hesitation. Mountain lions provide the clearest practical example. They are ambush predators, built to watch, approach quietly, and finish a chase with a short explosive burst. The National Park Service warns people not to run from one because running may stimulate its instinct to chase. It also advises standing upright, facing the animal, and avoiding crouching or bending over. Biologists think a standing person may not match the cat's ordinary image of prey, while a smaller four-legged outline can look more familiar. Notice how careful that wording is. May stimulate, can resemble. These are risk reduction principles, not promises about what every cat will do. Most mountain lions avoid confrontation with people, and attacks are rare. Still, our runner's posture communicates something important. Facing the cat preserves the tall, attentive, potentially dangerous human shape. Turning and sprinting removes eye contact, exposes the back, and supplies a clean, receding target. The cat has not become hungrier. The visual case for pursuit has simply become less ambiguous. Bears expose why the phrase predator brain can mislead us. Most dangerous bear encounters are not hunts. A surprised bear, a mother with cubs, or an animal defending food may be trying to remove a threat, not obtain dinner. The National Park Service therefore says there is no single strategy guaranteed to work in every bear encounter. Advice changes with the species and the situation. Yet the general warning remains: do not run or make sudden movements. Bears are faster than people, and fleeing animals can be chased. That does not mean running converts a defensive bear into a hungry one. It may add pursuit to an already dangerous defensive interaction. Even the correct response after physical contact differs. Guidance for a defensive grizzly attack can involve playing dead, while guidance for an attacking black bear generally says to fight back. This video is explaining a behavioral principle, not replacing local safety instructions. The animal, the distance, the presence of cubs, and the reason it approached all change the answer. Wolves add another complication. They are coursing predators, capable of following prey over distance, so a moving path is information they use extremely well. But wild wolves generally fear and avoid humans. Recent field experiments even found wolves responding strongly to human presence, reinforcing the super-predator paradox. Official guidance for an unusually close wolf still says not to run, stand tall, face it, make yourself conspicuous, and back away without offering a chase. Again, this is not because every wolf secretly wants to eat a jogger. A predator's brain balances approach against defense. Experiments on prey capture show those motivations can compete, especially when the target might also be dangerous. Running changes the balance by making your direction predictable and your posture less confrontational. It can reduce one reason to hesitate while strengthening a familiar movement pattern. The red ring therefore almost closes, but not completely. The animal can still stop, retreat, become distracted, or decide the risk is absurd. Evolution rewards successful pursuit, but it also rewards not getting injured by a confusing ape. Here is the answer. When you run, a predator does not necessarily relabel you from human to food. Instead, your movement can promote one step in an existing action sequence: orient, track, and pursue. At the same time, it hides some signals that normally make humans intimidating: height, attention, eye contact, and the appearance of being ready to resist. That is why the most accurate picture is not a kill switch. It is a contest between possible actions, with new evidence changing the winner. In our final scene, the runner stops, turns, remains upright, and slowly creates distance. The red tracking ring loses its direction, breaks into pieces, and disappears. That visual is a metaphor, not universal encounter advice. Before entering wild country, check guidance from the local park or wildlife authority for the exact animals there. The correct response to a cougar is not identical to the response to every bear. Understanding the predator's problem helps us control our own panic. Sometimes the safest looking instinct is the one worth questioning.